electronics and start to mount them in the cube. Although I thought the machining was finished, there were still some things to do, like making the heatsinks for the ESCs. I also milled out some transparent mounting plates. I always need to know the current orientation of the cube. For things like that I used this MPU 9150 in the past, but it's quite noisy and was always a pain to work with. So I decided to try out this Razor IMU. This board has the added advantage that it has its own programmable microcontroller, so you can do the needed orientation calculations on board and just send the result to the main microcontroller. I made a Cinder app to test it. Although I still need to do some tweaking and calibration, it seems to work really well. Up next is the remote control for the cube. I didn't want to use a bulky RC radio, so I decided to give this infamous Internet of Things thingy a try. It's the ESP8266 Wi-Fi module, very cheap and really cool. I needed a custom PCB to mount it. It's a simple design, so it was a good time to test out the PCB milling capabilities of my CNC. That worked out pretty good. After some soldering, it was time to start testing the ESP8266. I set mine up as a Wi-Fi access point with a web server, so the cube has its own Wi-Fi you can access with any internet-enabled device and its own web server you can connect to. It still feels unreal for a $3 chip. It also has a serial interface, so I can send data from the web server to the main microcontroller. And this is what it looks like with everything mounted in the cube. As you can see, I still have a lot of wiring up to do, and after that it will be a lot of programming. But I hope that in the next video I will finally have a working cube. So stay tuned and I'll see you next time.